What if you could learn data science, AI, cybersecurity, cloud computing, digital marketing, and even project management completely free? No fees, no catch. And yes, you get a certificate too. Welcome to Omni Academy, Pakistan's leading IT training institute since 2010, part of MHSG Consulting Group, helping thousands build real-world skills and land jobs. Every month, Omni Academy offers 50+ free workshops taught by industry experts covering everything from AI and cloud to cybersecurity, networking, and more. Whether you're a student, a professional, or just starting out, there's something for you. Join online from anywhere in Pakistan, Karachi, Lahore, Islamabad, or beyond. So don't wait. Register now at omniacademy.com and secure your spot today. Omni Academy, your career transformation starts here, and it starts free.
Hello everyone, and welcome to this free Cisco Certified Network Associate (CCNA) workshop. We're excited to have you here today. Whether you're a student, a fresh graduate, an IT enthusiast, or someone planning to start a career in networking, you've made a great decision by joining this workshop. Networking is the backbone of today's digital world. Every website you visit, every email you send, every video call you make, and every cloud application you use depends on computer networks working efficiently. Behind those networks are skilled professionals who design, configure, troubleshoot, and secure them. That's exactly where CCNA comes in. The Cisco Certified Network Associate (CCNA) certification is one of the most recognized and respected certifications in the IT industry. It doesn't just teach you how networks work. It prepares you for real-world networking jobs. Many companies around the world, from startups to multinational organizations, value professionals who hold a CCNA certification because it demonstrates practical networking knowledge and problem-solving skills. If you've ever wondered questions like, how does the internet actually work? What happens when you connect to Wi-Fi? How do computers communicate with each other? What are routers and switches really doing? How does data travel from one country to another within seconds? Then you're in the right place. Today's workshop is designed for complete beginners as well as those who already have some IT knowledge. Don't worry if you've never configured a router before. We'll keep everything simple, practical, and easy to understand. Our goal isn't to overwhelm you with technical jargon. Instead, we want you to understand the concepts that form the foundation of networking. Throughout this workshop, we'll explore what CCNA is, why it's valuable, what you'll learn during certification, career opportunities after becoming certified, and how you can begin your networking journey, even if you're starting from zero. By the end of this session, you'll have a much clearer understanding of whether CCNA is the right certification for your career goals and what your next steps should be. So grab a notebook, stay focused, and let's begin our journey into the world of computer networking. Now that we understand why networking is so important, let's talk about the certification itself. So what exactly is CCNA? CCNA stands for Cisco Certified Network Associate. It is an entry-level professional certification offered by Cisco, one of the world's leading networking companies. Cisco equipment powers networks in businesses, universities, hospitals, banks, government organizations, and internet service providers across the globe. The purpose of the CCNA certification is to validate that you have the knowledge and practical skills needed to install, configure, operate, troubleshoot, and secure modern computer networks. One of the biggest misconceptions about CCNA is that it's only for networking engineers. That's simply not true. CCNA is valuable for students planning an IT career, fresh graduates looking for their first job, help desk and IT support professionals, system administrators, cybersecurity beginners, cloud computing enthusiasts, anyone who wants a strong foundation in networking. In fact, many cybersecurity professionals start their journey with CCNA because it's difficult to protect a network if you don't first understand how it works. Let's take a quick look at some of the major topics covered in the CCNA certification. The first topic is network fundamentals. You'll learn what a computer network is, the different types of networks such as LAN, WAN, and WLAN, how devices communicate, and the role of networking hardware like routers, switches, and access points. Next comes the OSI model and TCP/IP model. These models explain how data travels from one device to another through different layers. While they may seem complex at first, Understanding them makes troubleshooting network issues much easier. You'll also study IP addressing and subnetting. This is one of the most important parts of CCNA. You'll learn how devices receive IP addresses, how networks are divided efficiently, and how to calculate subnets. Although subnetting often sounds intimidating, with the right guidance and practice, it becomes much easier than most people expect. Another major topic is switching. You'll understand how switches connect devices within a local network, how VLANs improve network organization, and why switching is essential in modern office environments. Then you'll move on to routing. Routers connect different networks and determine the best path for data to travel. You'll learn how routers make these decisions and how to configure routing in real-world scenarios. As your skills grow, you'll also explore wireless networking, where you'll understand how Wi-Fi networks operate, how wireless devices connect securely, and the best practices for designing reliable wireless environments. Security is another essential part of the certification. Modern networks face constant cyber threats. So, CCNA introduces network security concepts such as access control, device hardening, password protection, firewalls, and basic security policies that help protect network infrastructure. Finally, you'll be introduced to automation and programmability. Networking is evolving rapidly, and organizations are increasingly using automation tools to manage large-scale networks efficiently. CCNA provides an introduction to these modern technologies, helping you prepare for the future of IT. As you can see, CCNA isn't just about memorizing commands. It's about understanding how networks function, how to solve real-world problems, and how to build the practical skills employers expect from networking professionals. Let's start with a simple question. Imagine you've written a letter. You place it in an envelope. You write the address. You hand it to the courier company. The courier sorts it, transfers it between cities, finally delivers it to the correct person. Simple enough, right? Now think about sending a WhatsApp message. You type a message, press send. Within a second, it reaches someone on the other side of the world. Have you ever wondered, how did your phone know where to send it? How did the message travel? How did it avoid millions of other devices connected to the internet? How did it reach exactly the intended recipient? All of that happens because of networking. Computers communicate using rules. Devices have addresses. Routers make decisions. Switches connect systems. Servers respond to requests. Everything works together like an incredibly organized transportation system. Today, we'll begin understanding that system. What exactly is a computer network? Let's keep this as simple as possible. A computer network is simply a group of devices connected together so they can share information. That's it. Those devices could include desktop computers, laptops, mobile phones, servers, printers, security cameras, gaming consoles, smart TVs, cloud servers. Even refrigerators and washing machines today can connect to networks. Whenever two or more devices communicate electronically, they are forming a network. That's the basic idea. The network may be very small, for example, two laptops connected together. Or it may be enormous, like the internet itself. The internet is simply the world's largest computer network. Millions of smaller networks connected together. Why do we need networks? Let's imagine a company with 150 employees. Every employee has their own computer. Without networking, each employee would have to store files individually. Printers would need separate connections. Sharing documents would require USB drives. Employees couldn't access shared databases. Emails wouldn't work internally. Internet connections would become extremely inefficient. Now imagine the same office with a properly designed network. Everyone shares resources. Files are stored centrally. Printers are shared. Internet access is managed. Security policies are applied. Data backups happen automatically. Employees collaborate efficiently. This is why networking has become essential for every modern organization. Banks rely on networks. Hospitals rely on networks. Airports rely on networks. Schools rely on networks. Universities rely on networks. Factories rely on networks. Government departments rely on networks. Even small shops now rely on networks for billing systems, inventory management, and online payments. Without networking, modern businesses simply cannot function. Why should you learn networking? Suppose you're thinking about starting a career in IT. Many beginners immediately focus on programming. Some choose cybersecurity. Others start learning cloud computing. But here's something interesting. Almost every IT field depends on networking. If you're a cybersecurity professional, you must understand networks. If you're a cloud engineer, you must understand networks. If you're a system administrator, you must understand networks. If you're working with Microsoft Azure, networking is essential. AWS, networking. Google Cloud, networking. Virtualization, networking. DevOps, networking. Ethical hacking, networking. Network knowledge is one of those skills that strengthens almost every IT career path. That's why CCNA is often recommended as one of the best starting points for anyone entering the technology industry. Types of networks and understanding network devices. What is a network, really? Earlier, we defined a network as a group of devices connected together to share information. But not every network is the same. Some networks cover a single room, some cover an entire building, some connect cities, some connect countries, and one network connects almost the entire world. The main difference between them is size, purpose, and distance. Let's look at each one. Personal Area Network, PAN. We'll start with the smallest type of network. A personal area network, or PAN, is a network built around one person. Think about your daily routine. You connect your wireless earbuds to your phone using Bluetooth. You pair your smartwatch with your phone. You transfer files between your laptop and mobile device. These are all examples of a PAN. The devices are close to each other, usually within a few meters, and communicate using technologies such as Bluetooth or USB. Although simple, PANs are still networks because devices are exchanging information. Local Area Network, LAN. Now let's move to something much larger. Imagine you're in a school computer lab. There are 30 computers, a printer, an internet connection, maybe a server storing student records. All of these devices are connected together. This is called a local area network, or LAN. A LAN usually covers a limited area, such as a home, an office, a classroom, a university campus, a small business. LANs are fast because the devices are physically close together. This is the type of network you'll encounter most often as a network administrator. Wide Area Network, WAN. Now imagine a company with offices in Karachi, Lahore, Islamabad, Dubai, and London. Each office has its own LAN. But the company wants every branch to communicate as if they're in the same building. How is that possible? By connecting those LANs together using a Wide Area Network, or WAN. A WAN covers much larger geographical areas. It often uses internet service providers, leased lines, or other communication technologies to connect distant locations. The internet itself is the largest WAN in existence. Every time you browse a website hosted in another country, you're using a WAN. Metropolitan Area Network, MAN. There's another type called a Metropolitan Area Network, or MAN. As the name suggests, it usually covers a city or a large metropolitan area. For example, a university with multiple campuses across a city might use a MAN to connect them. Internet service providers also use MANs to deliver services throughout urban areas. Wireless Local Area Network, WLAN. Most of us use this every day without thinking about it. A Wireless Local Area Network, or WLAN, is simply a LAN that uses Wi-Fi instead of Ethernet cables. When you connect your phone or laptop to your home's Wi-Fi router, you're joining a WLAN. The advantage is convenience. You don't need cables running everywhere. The trade-off is that wireless networks can be affected by distance, interference, and physical obstacles like walls. Quick recap. Let's summarize. PAN connects personal devices over a short distance. LAN covers a home, office, or building. MAN covers a city or metropolitan area. WAN connects networks across large distances. WLAN, a wireless version of a LAN. Understanding these network types is one of the first steps toward understanding how modern communication works. Essential networking devices. Now let's meet the hardware that makes networks possible. Imagine a city without roads, traffic lights, or highways. Cars wouldn't know where to go, traffic would be chaotic. Networking devices perform similar roles. They guide, organize, and control the flow of data. Let's start with the most important ones. Router. The router is often called the traffic manager of a network. Its job is to connect different networks together. For example, your home network is one network. The internet is another network. Your router connects the two. When you open a website, your router decides where your data should go. It examines the destination and forwards the information along the best available path. That's why it's called a router. It chooses routes. Without routers, the internet simply couldn't function. Switch. Many beginners confuse switches with routers. Here's an easy way to remember the difference. A switch connects devices within the same network. A router connects different networks. Imagine an office with 50 computers. Those computers need a way to communicate with each other. Instead of connecting every computer directly to every other computer, they all connect to a switch. The switch learns which device is connected to which port and forwards data only to the intended destination. This makes communication much faster and more efficient. In modern business networks, switches are everywhere. Hub. Years ago, hubs were commonly used. A hub is much less intelligent than a switch. Imagine you're in a classroom and someone asks one student a question. Instead of speaking only to that student, the teacher shouts the question to everyone in the room. That's how a hub behaves. Whenever it receives data, it sends it to every connected device. Most devices immediately ignore the information because it isn't meant for them. This creates unnecessary traffic and reduces efficiency. For this reason, switches have almost completely replaced hubs in modern networks. Wireless access point. A wireless access point allows wireless devices to join a network. In many homes, the router already includes Wi-Fi functionality. In larger environments like universities, shopping malls, airports, and offices, dedicated wireless access points are installed to provide strong wireless coverage across the entire building. As a network administrator, you'll often configure and manage these devices. Server. A server is simply a computer that provides services to other computers. File servers, email servers, web servers, database servers, print servers. When you open a website, you're communicating with a web server. When you check your email, you're communicating with a mail server. Servers are the backbone of most business networks. Firewall. A firewall acts like a security guard. Imagine an office building with a guard checking everyone entering or leaving. The firewall performs a similar function for network traffic. It examines incoming and outgoing data and decides what should be allowed and what should be blocked. Firewalls help protect organizations from cyber threats and unauthorized access. An easy way to remember the OSI model. Many students use memory techniques. One common example is, please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, application. Whether you use this phrase or create your own, the important part is understanding what each layer does, not just remembering the names. What about the TCP/IP model? Now let's briefly discuss another model you'll hear about frequently, the TCP/IP model. Unlike the OSI model, which has 7 layers, the TCP/IP model has only 4. Those layers are application, transport, internet, network access. The TCP/IP model is the one actually used on today's internet. The OSI model is primarily a learning framework that helps us understand networking concepts. Think of it this way. The OSI model teaches us how networking works. The TCP/IP model shows us how modern networks are actually implemented. As a CCNA student, you should be comfortable with both models and understand how their layers relate to one another. Mini quiz. Let's test your understanding. Which OSI layer is responsible for routing? Which devices mainly operate at the data link layer? Which protocol provides reliable communication, TCP or UDP? Which layer is responsible for encryption and decryption? Which layer handles cables and electrical signals? If you answered network layer, switches, TCP, presentation layer, physical layer, excellent. You're building a strong networking foundation. In the next session, we'll move into another essential CCNA topic, IP addressing, IPv4, IPv6, and subnetting. This is one of the most practical and frequently tested areas of the CCNA exam, and by the end of it, you'll understand how devices are uniquely identified and communicate across networks. IP addressing, IPv4, IPv6, and introduction to subnetting. What is an IP address? An IP address stands for Internet Protocol Address. Just like every house has an address for receiving deliveries, every device on a network needs an address to send and receive data. Without an IP address, computers would not know where to send information. Why do devices need unique IP addresses? Every device on a network needs a unique IP address. Think of a classroom where 5 students have the same name. The teacher would not know who they are calling. Networks work the same way. Duplicate IP addresses create communication problems. Public IP versus private IP. There are 2 main types of IP addresses. Public IP address is provided by your Internet Service Provider, ISP, and is visible on the Internet. Private IP address. Private IP addresses are used inside homes and offices for devices like laptops, smartphones, printers, smart TVs. Routers use network address translation, NAT, to allow private devices to access the Internet using a public IP. IPv4. IPv4 is the most commonly used IP version. It uses 32 bits and is written in 4 sections called octets. Example, 192.168.1.10. Each octet ranges from 0 to 255. However, due to the huge growth of Internet-connected devices, IPv4 addresses became limited. This led to the development of IPv6. IPv6 uses 128 bits, providing a much larger number of addresses. Example, 2001.0db8, 8583, 8A2E, 0370, 7334. The main purpose of IPv6 is to solve the shortage of IPv4 addresses. Static versus dynamic IP address. Static IP address is manually configured and does not change. Commonly used for servers, routers, CCTV systems, network printers. Dynamic IP address. Dynamic IP addresses are automatically assigned using DHCP, Dynamic Host Configuration Protocol. DHCP provides IP address, subnet mask, default gateway, DNS server. What is a subnet mask? A subnet mask helps a device understand which part of an IP address represents the network and which part represents the host. Example: IP address 192.168.1.25, subnet mask 255.255.0. Network 192.168.1, host 25. Why do we use subnetting? Subnetting means dividing a large network into smaller networks. Organizations use subnetting for better performance, improved security, easier management, reduced network traffic. It helps companies organize large networks efficiently. Private IPv4 address ranges. These ranges are commonly used in private networks. Class A, 10.0.0.0 to 10.255.255. Class B, 172.16.0.0 to 172.31.255.255. 192.168.0.0. 192.168.255.255. Quick review. What does IP stand for? Answer: Internet Protocol. Which protocol assigns IP addresses automatically? Answer: DHCP. Which IP version uses 128 bits? Answer: IPv6. Why is subnetting used? To improve network performance, security, and management. Now that you know what CCNA covers, let's answer one of the biggest questions people usually ask. What can I actually do after getting CCNA certified? The good news is that CCNA opens the door to a wide range of career opportunities. Every organization today relies on computer networks. Whether it's a school, a hospital, a bank, a software house, an e-commerce company, a telecom provider, or even a government department, they all need skilled networking professionals to keep their systems running smoothly. With a strong understanding of networking and a CCNA certification, you can apply for roles such as network support engineer, network administrator, IT support engineer, technical support engineer, junior network engineer, system administrator, infrastructure support engineer, NOC, network operations center engineer, desktop support engineer, field network technician. As you gain experience, your career can grow into more advanced positions like network engineer, senior network engineer, network security engineer, cybersecurity analyst, cloud network engineer, infrastructure engineer, solutions architect, IT manager. One of the biggest advantages of learning networking is that it's a skill needed across almost every industry. Unlike careers that are limited to a specific field, networking professionals can work in healthcare, education, banking, manufacturing, telecommunications, software development, cloud services, logistics, and many other sectors. This flexibility gives you more job opportunities and greater career stability. Let's also talk about salaries. The exact salary depends on your country, experience, technical skills, certifications, and the company you work for. However, professionals with strong networking knowledge and practical experience are often offered competitive salary packages because businesses cannot operate without reliable network infrastructure. As you continue learning and earn additional certifications in areas like cybersecurity, cloud computing, or network automation, your earning potential can increase even further. Now, many beginners often have another question. Can I learn CCNA if I have no experience? The answer is absolutely yes. Every networking professional started as a beginner. No one was born knowing IP addressing, routing protocols, or subnetting. The key is to learn step by step, practice consistently, and build confidence through hands-on experience. One of the best things about CCNA is that you don't need expensive networking equipment to begin learning. You can practice using network simulation tools like Cisco Packet Tracer, where you can create virtual networks, configure routers and switches, troubleshoot problems, and experiment with different network designs, all from your own computer. This practical approach allows you to develop real skills before working with physical networking devices. Remember, networking is not about memorizing hundreds of commands. It's about understanding how devices communicate, identifying problems logically, and applying the right solutions. The more you practice, the more comfortable you'll become. Consistency is far more important than speed. Even if you dedicate just 1 or 2 hours a day to learning and practicing, you'll make steady progress over time. Don't compare your beginning with someone else's years of experience. Focus on improving one concept at a time. Every subnet you calculate, every router you configure, and every network issue you solve brings you one step closer to becoming a skilled networking professional. If you stay committed, keep practicing, and continue building your knowledge, CCNA can become the foundation of a long and successful career in information technology. As we come to the end of today's workshop, let's discuss one final but important topic: how to prepare effectively for the CCNA certification exam. Many students think watching videos is enough to pass CCNA, but success requires a combination of strong concepts, regular practice, and hands-on experience. Here are some tips to help you prepare. 1. Build strong fundamentals. Before moving to advanced topics, make sure your basics are clear. Focus on important concepts like IP addressing, subnetting, OSI model, and TCP/IP. 2. Practice regularly. Networking is a practical skill. Spend time configuring routers, switches, VLANs, and IP addresses. Even 30 minutes of daily practice can make a big difference. 3. Use Cisco Packet Tracer. Practice building virtual networks, configuring devices, and troubleshooting different scenarios using Cisco Packet Tracer. It is a great tool to gain practical experience. 4. Focus on understanding. Don't just memorize commands. Understand why a command is used and how networking concepts work. This will make learning much easier. 5. Stay consistent. Some topics may seem difficult at first, but regular practice and patience will help you improve. Before we conclude, let's quickly recap what we covered today. What CCNA is and why it is a valuable networking certification. Core topics, including networking fundamentals, IP addressing, switching, routing, security, and automation. Career opportunities available after completing CCNA. Tips to prepare effectively for the certification exam. We hope this workshop helped you understand the CCNA journey and how it can support your IT career goals. Thank you for joining us today. We truly appreciate your participation. Before you leave, here are some exclusive opportunities for our workshop participants. 20% off on our premium courses. As a thank you for attending this workshop, you can get 20% discount on our professional training programs. This offer is valid for the next 7 days. PM. Join our free WhatsApp learning community. Stay connected with us and receive job and internship opportunities, free learning resources, workshop updates, career guidance and tips. Continue your learning journey. Remember, this workshop is just the beginning. Keep learning, practicing, and improving your skills to build a successful career in networking and IT. Thank you once again for attending our free Cisco Certified Network Associate (CCNA) workshop. We wish you the best for your certification journey and future career. Stay curious, keep learning,